Welcome to the session. Greeting of the day. In today's class, we will see about the remaining topics of solid state welding methods. We have, in the starting, we have seen from this gas welding methods, arc welding methods, resistance welding, and we are on now on the solid state welding process. On that, we have already seen about friction welding and explosive welding process we have seen. Now we will see about the remaining part of a forge welding processes. The forge welding, the welding process in which the components to be joined or heated to hot working temperature from the range and then forged together by hammering or similar means. We are doing the simple hammering process we are doing. See, this name terminology forging belongs to hammering process, heating process. How we are done? A very simple two components we have taken of very simple of two components we have taken of two, and then we have kept one over the other. It is not but. We have to kept two components one over the other. It is a heated point. After heating, I want to heat hammering here process. What happens this locations? It is already heated as shown in the picture. It is already heated. We just heated point. We are keep on heating by a huge hammering force. Due to this forcing actions, this two metallic bonding will mix at red hot condition. It is not melted. It is a red hot plastically deformable condition. We naming this as a plastically deformed condition. It can be deformed. It can be able to change the shape at red hot condition. That we are heating. It means a hot working process. It is nothing but a hot working. We are doing the hot working process. At red hot condition, I am heating. After heating, the metallic bonding one over the other, it is made. Mixing of the A component and B component are done. After doing that, if required, some other secondary operations of bendings and other assemblings or shape changing process we can able to do. But the agenda is component A and component B are kept lab and hammering done at the hot working temperatures, and then therefore the metallic bonding occurs due to its impinging force actions by the pressure. What we have done, both the heat and pressures are applied in this process. Heat, hot working along with the forging actions are done together by hammering and other segment. Maybe hammer or maybe automated system like a die and a punch also we can use. Anyhow, it will be a hammering treatment or forging. Pressure force application method. So the process is familiar to the traditional method using the blacksmithing process. The forces can be applied by a manual blows continuously or repeatedly by a machine or by the rolls. So the forging to be done, the forging action may be a roll forging, that is called as a roll. See, roll welding process. So we have used the method here also, the rolling. So we have used the rolling or forging. So anything, maybe a roller, maybe a forging operations. Therefore, we can tell about this. It can be maybe a rolling or maybe a forging setup. How will be the forging setup? We have the die, and we will have the red hot molten semi-plastic deformable material, and over there we are going to put the punch here. Punch force will be there. Accordingly, the forging will happen and it will be welded. Two components what we need, we have to keep there. It is one of the oldest known process to the mankind. Yes, that is okay. So therefore, and then in this process, the end of the parts to be joined, 2 points, lap joints actually, are heated to the temperature slightly below the solidus temperature line. It means below that is, above it is a liquidus line, solidus line. Below the solidus line, what is this? We know this actually. So this point. So we have seen this. So above this it is liquid. This is a solidus line. Here liquid plus solid. We are heating up to this location only. we are working is, this location is called as a hot working condition. So above that it will become liquid, we are not doing, it is a solid state joining process, forging, a red hot condition, it's at the temperature below the solidus line. So after that we are heating and application of pressure, heat and pressure we are applying to make the joining process. What are the process variables then here? So forged welding temperature, how much we are heating, it means the solidus line will be different for steel, solidus line will be different for aluminium, it depends upon the alloy system. Therefore, how much temperature we have to heat and the amount of deformation, how force we have given there. Hammering is a very manual, is very small force, but the machine force is very large. How much force? It depends upon thickness. Depends upon thickness of this component A, thickness of the component B, how thickness it is, how force needed to make the welding points. And the forging speed, how fast we are coming with high velocity to create that force. So those things. Typically, 50 to 90% of the melting temperature, the solidus line at usually it will be 50 to 90%. Above that it is liquid. The 10 to 20% differs upon the solidus temperature. Soft low carbon steel having, we can able to do this process because still having, we know this point, still having the melting point of around how much? It is the 1550 or 1500. So in this red hot conditions we are working around 1250 degrees centigrade. So 80 to 90%. So high carbon alloy steel having around 1100 to 1150. Therefore this depends upon the alloy systems and the material. This oxide layer has to be removed before further welding passes. Flux is applied so that the oxide layers become more fluid under the various conditions of the joints. It is a slow process because we are manually heated and then welded. It is somehow a very slow process and a more labor intensive process. It is a more labor intensive process. We have seen in that video an employee is heating and work, it is a labor intensive and also skill is required. Where we are hitting and how far it is changing its shape, how far welding is done based upon the thickness. So it is labor intensive, labor skill is required in this. The quality depends upon more on the, see the next time they have given, more on the skill of the welder. It is on the skill of the welder. So various types how we can able to do this forge welding process. Maybe in this lab format or maybe in this format or maybe a butt format, self jump or a lab process. So here the welding to be done, here the welding to be done, here the welding to be done, here the welding will be done. For the force applied it will closes likewise. So a simple sketch I have given where the two components are taken and hammer have been force lower given and then the welding has been completed easily. So very simple manual method. It can be machined also. It can be mechanized and we can able to do. When the specimens are kept down, when the machine is forcefully coming and hitting, it is a mechanized process. Instead of hammering of mechanized process, when you are hammering, it is a manual process. So anyhow we have to keep two lap pieces and then the machine should come and hit. So that is a mechanized and manual. It can be. So we are using tools such as anvils. Over there you have to keep. So see in this video we are using anvils. See they are kept, the workpiece is kept, hitting process done at red hot conditions. Both are metallurgically bonded. So it is a simple method of forge welding methods. So I would like to play a small video clip here for our understandings. You see how this square corners and flat corners are welded. See how they are doing. So this two corners they have taken first. They want to make a bucking joints there. How they are red hot conditions. They are going to cut those specimens at the corner. Now the specimen is cutted, but it's normally not possible to cut at the normal cold conditions, cold working. You can able to do at a hot working conditions. So after doing the cutting process, is ready to welding. So now he is red hot conditions, changing shape he is doing. So how the broadening and all these things, changing of shape he is doing for making the welding connections. See how it will be done. So see how we have seen this part is sliced out first. After slicing out, he is flattening to make a butt joint. To a lap joint, to do this lap joint, he is preparing the two specimens, one over the other. After making, so second specimen he is making, second specimen. After the second specimen is made, see how they have kept. At radar condition, the corner they have sliced out. This corner they have sliced out. And then they are assembled now. After assembling, they are putting into the furnace and heated those corner points. Both are heated but not welded. They are taken out from the furnace and hammering those points, the lap joint points, and now it is welded. It is metallurgically bonded, mixing. Diffusion happens inside between the component A and component B. And therefore, he is assembling the perfections of joints also, shaping he is doing by the welder. It's a skilled work. It is a skilled work. Forged welding requires a skilled of the welder, more skilled when compared to the other process. So how very simply he had able to do this treatment. Very simple methods. Some of the images I would like to show you here. Some see the furnaces, how he is utilized and taken out, and how this welding process of forged welding manually, how they are doing. The same like a video, I want to show you some few images. Forged materials, therefore, we can able to weld maybe the aluminum alloys, magnesium alloys, copper alloys, marten stick stainless steels, austenitic stainless steels, and nickels and titanium alloys. Any material can be welded by using this forged material manual welding process, manual or automatic process. What are the advantages here? You see, it is simple and easy. No costly equipments are used. Weld both similar, dissimilar, good mechanical properties. No fillers. In electric arc method, SMAW, flux core arc welding, SAW process, MIG, TIG, all process they have used fillers, but here no fillers. Only both materials are used. So limitations only for smaller objects. If I am using a large object, manual hitting, hammering not possible. Therefore, we have to use a large object, large presses we needed, large presses machine setups. Therefore, we are converting from manual to the machine setup when the component getting large. So high skill of the for hammering. Now only we have seen a video clip. There we have seen the hammering process. Very skilled laborers are needed here. Skilled welders. So welding defects involves, it's done at the open environment, hot temperature. With the hot temperature, hydrogens at hot temperature, the atmospheric entrapments will happen. Atmospheric contaminations will happen at the high temperatures. So we are not closed. Protection is not given. Shielding is not given. So defects are possible. No mass production because one on one we are doing. No mass production. Slow welding process. Slowly we have to hit furnace and then doing manual. It's a slow welding process. Applications, joining of steels and irons, using in the cookwares, manufacturing of gates, prisons like this, some other grills, homemade applications. Normally, you are seen in the streets and other shops, in the buildings or grill making shops, usually in and around our houses. Weapons like the swords, so the swords are not made by this forging. In the streets, we have seen some they are sitting and firing and then putting this preparation of knives, all by using this forged welding methods. There is one superb method of getting the marten side for the sharp and brittle. Some method is there. Why they are making after hitting, putting into the water? That quenching treatment they are doing. This quenching treatment increases the hardness, so that is helpful in the knife. So now we have done this solid state welding process. Now we want to concentrate on the thermit welding methods. And the next one, the thermit welding. So thermit welding, see, in this process welding is done by pouring a superheated liquid steel around the parts to be joined. Shortening molding process to be done before welding methods. By weight, 75% of iron oxide and 25% of soft fine aluminum. This is number one component. Iron, and second component of aluminum we are using. Fine aluminum powder and iron oxide should have the ratio of 1:3. Thermit welding is done by the chemical reaction. By the chemical reaction, heat is generated. So see, the main methods, cleaning of the joint and then construction of the mold, preheating, preparation of the thermit mixture and igniting, crucible and charging. Thermit welding will to be happen post secondary operation. If needed, we can able to do. So this one by one we have to see. The end of the parts to be joined are kept parallel with uniform gap. You see, we have taken two railway track that has to be done, a gap to be filled here. So which one I'm talking about, this gap to be filled. So the materials are coming from here. It should be come down. Where it is this red color belongs to iron. But iron normally when it will not form, heat is to be generated. Therefore I am using iron powder of 75% and aluminium of 25%. When it is mixing of reaction takes place, aluminium oxide goes out and iron will be melted due to that heat, and that iron will be as a casting, like a casting process we are pouring here and making the welding process. So likewise we have to do cleaning of the joint first we have done, and then construction of the mold. Around this we are going to make a molten metal to be solidified inside. And we are not talking about the solid state joining. Solid state joining is over. The thermit welding. Here the molten metal will be there. We have to join two specimens this one, and therefore I am creating a mold, sand mold around there. So this is the sand mold I have created. So this is the sand mold I have created. See, around the specimen which is to be welded. Likewise, we can tell the sand mold between the railway track welding process. Sand mold has been created around there, and I have kept the box which contains iron and aluminium. When it is fired, aluminium oxide will form, which generates more heat, and then this iron will melt and will flow over the inside. Will flow over the inside in the gap like this. In the gap it will flow. In the gap it will flow. Therefore, what I am doing, see here, super hot steel from thermit reaction. Super hot steel from thermit reaction we have inside. Those things we are heated first. After heating it will become molten. This molten we are supplying inside. See, it is supplied inside the gap, and therefore it is filled here. Now it is filled. After filling it will come out. If it is coming out, we can understand that it is filled. And we are removing the constructions of mold preparations, and we are breaking those molds, and what will be there? The iron, the molten metal, the solidified with the railway track. So that is completed welding. So what happens? I have taken iron and aluminium, the mixture, heated, fired, heat generated, aluminium oxide generates heat, therefore this iron also melted and it is flows down and it is there. So this is a simple removal methods. The secondary operations they are doing. They have to remove and graining and those things for making of the proper perfect railway track. But the technique, where is the technique? Technique is here. Iron and aluminium oxide. Heated, welded. And it is poured over there to fill the gap like a simple casting method. We have the sand molding around to protect. That's it. So after that removal, we can able to see how it will be. After they have to remove. So what we are doing? Construction of the mold. First the cleaning we have done. After cleaning, construction of the mold, the sand mold we have done. Preheating of the mold. So some warmer preheating of the mold. Otherwise this heat will be also consumed by the sands. That is not to be happen. Therefore I have preheated the mold also. After preheating the mold, preparation of the thermit mixture. Preparation of the thermit mixture and igniting. We have kept the box which contains the iron powder and the aluminium powders which is kept inside, and we have to fire them. So this preparation of the thermit mixture is nothing but a box it will be there. See, in the joint, this is how this will come. Finally it will form there. The gap we have welded using the thermit reaction. Thermit welding process. Next, the next point, the crucible and charging. So the mixture is ready. We have kept in the crucible, the box that is called a crucible, and then we have charged, we have fired. After firing, what happens? Thermit welding will take place by heat plus melting and plus pouring over the gap. That has been done. After this, what I am doing, the post-secondary operations of removal. Removal can be done. Very simple method. The thermit reaction and then melting, pouring, solidifying, removal. So this ends up to be joined and kept parallel with the uniform gap between them. Yes, the uniform gap between them we are keeping. That the gap is filled with the wax, which becomes the pattern. Molding sand is ramped around the wax patterns. Pouring, heating, as like gating systems, as like casting. Here also the gate is there. The top one is gate where we are pouring. So this one is gate inlet and coming and going outside. Simple methods. So see, the reaction takes place. What is the reaction takes place here? Iron oxide plus aluminum we are adding. What happens there? Aluminum oxide is formed. Aluminum is added with iron oxide. Aluminum oxide is formed plus iron plus heat. So this is very important. So this reaction. So this reaction generates the heat there. See, iron oxide powder, aluminum powder we have taken, combined, and we have started to heat. It means the charging done. Aluminum oxide formed which is heated, and iron and heat. This heat melts the iron. This heats melts the iron, and this iron are dropped in the cavity where we need, and therefore the welding completes. Very simple methods. The crucible is placed directly above the joints. The crucible is placed, the box, now only we have seen that box in the video. The crucible is placed directly above the box joint to be welded. After preheating of the joint, liquid thermit steel, the liquid thermit steel from the crucible is poured into the mold between the gap of the weld, the two gaps. We have kept the crucible here. We have kept the crucible here and we have fired. After firing, due to this gap, it comes down and this gap has been filled. So that is why the molten metal solidifies and the weld is completed. Very easiest method. That reaction, this reaction, iron oxide plus aluminum gives aluminum oxide plus iron plus heat. This heat melts the iron. So after removing of the mold, the riser and the gating systems are cut. So that is what we have seen in the video also. Are cut away, but cutting torches and the joints to be prepared perfectly. It's to be taken care. It should not damage our workpieces. So that is what the thermit ignited. The thermit has been ignited. Then crucible tapped. Open. Crucible is open. After ignition, crucible to be open. Tapped out to flow. To flow to be takes place here. The flow to be takes place here. Crucible superheated metal will flow. Superheated metal will flow into the mold. The metal solidifies to produce the weld joint. So this is the same image only that we have seen there. Assembled, superheated tapped out. Motor comes down, fills the gap. After filling it, it comes out through the gating systems, and we can able to find it is filled, and we can able to remove break the molds, and we can move out the crucible also. Break and component is ready after the secondary treatments. So I want to show you a small video clip here. So the same what we have seen there. See how they are making, and it can be welding has been done. So see some images. So little bit it is a closed view we can get here. See some crucible heated and pouring there. So likewise tapping out, and we can able to take care. Few images. So likewise, see it is filled and iron metal comes out through the gating system. In such a way we find the inner gap is completely filled. Until then we should wait. Sufficient volume to be given, iron powders or aluminum, sufficient volume to be given. So after that we are these molds are break. These molds are break to create the weld configurations. So it is welded now. Gap positive welding process. We have used fluxes like aluminum and this one. Molten metal. Fusion welding happens here. It's not a solid. Metals is melted and deposited there. Iron. So the applications and advantages. So it is a portable one. It is a simple component. We can take the crucible and firing and the gap. That is what we need. Simply we are keeping firing, the powder, the crucible which contains the iron powders and aluminum powders will get fired, charged. Immediately it is fired and smelted and deposited. Simple casting method we are using in terms of thermit welding with respect to the reactions. No external power supply is needed. No power supply. Yes, accept. No power supply because it is a crucible welding. Repairing broken parts we can do. Simple any repairs like our railway tracks, any breakages or it's happened, we can able to go directly to the specific location and we can able to do the repairing in the spot, on spot welding, on spot, not a fabrication, on spot repairing you can do. Therefore, I am naming this as an on-site welding. Wherever the repair is there, we are going there. Usually we are fabricating at what location and utilization in the other location. Preparation of pressure vessels are done in the fabrication industry and the working of the plant is somewhere. So that is not happened here. If the repair is happened, this thermit welding component we can take and we can go there and we can weld. It's a very simple method. So applications is repairing of fracture rails, butt welding pipes and ends to ends, welding large fractures and crack shafts, and welding broken frames by the machines. Broken frames, broken parts can be welded, connected. So this happens, a large fractured crankshafts. We have to keep and thermit welding to be done. What are the limitations here then? So limitations is only ferrous material can be welded. By the thermit reaction we have seen iron oxide plus aluminium. So aluminium and iron only is coming out due to heat. Therefore it is only for ferrous materials. Thermit mixtures cannot be stored due to safety hazards and should be used very soon. What we are doing, this chemical reaction takes place in blasting. It's like minimum blasting, like explosive welding also. This is also in blast. Therefore, this also to be taken care very perfectly. Otherwise, this will make some problem to the employees. Therefore, it should be handled or it should be consumed very quickly. No external power supplies. That is one of the advantage that is okay. Cheap process for repairing or broken parts. So these are not some advantages. Mainly these limitations to be are considered. So few images we can do. Instead of forge welding, the rolling also is there. See, roll welding process. Simply by utilizing the rolling process, we can able to do this rolling methods. The summary. In welding, we have done about the thermit welding process. Thermit welding process and in solid state welding we have seen about the explosive welding and we have seen about the forge welding and the roll welding process. For all these things we have seen the advantages, limitations and applications. The remaining part of this subject we'll see you in the next session. Thank you.